Hi, welcome to my review 2 on congruent triangles. The previous video was on review 1. And we have some proofs to do. Again, pause the video and see if you can do these proofs before I do them. Here we go. We're given that angle 1 equals angle 2. Okay. We're also given that HV bisects KT. HV bisects KT, so that means that KV would equal KT. And we want to prove that HV bisects angle KHT. So that means I need to get this angle right here equal to this one. If I can get these two angles equal, then it's a bisector. To get those two angles equal, we might need to do congruent triangles. So can I get a pair of triangles congruent? Well, let's see. I have angle 1 equals angle 2. So if I put 5 and 6 right here, these are supplementary. These two are supplementary. So that means 5 is going to equal 6 by SAT. And as a result, if I say HV is equal to itself, common side, I have an angle ASS, and I can't say that right now. So what we'll do, because we have 5 equals 6, we'll say that HK is equal to HT. Converse of ITT, two angles equal, two sides are equal. That gives us the triangle is congruent by SAS, and therefore 3 is equal to 4, CBCTC, and therefore it's a bisector. So here we go. Angle 1 equals angle 2, and HV bisects KT. And again, I said, check with your teacher to see if you're allowed to put all the givens in the first statement, or do you have to keep them separate. So 1 is equal to 2. That means angle 1 and angle 5 are a linear pair. Angle 6 and angle 2 are a linear pair. And that's the definition of a linear pair. And a linear pair is two adjacent angles that are supplementary form a linear pair or form a straight angle. And as a result, angle 1 is supplementary to angle 5, and angle 6 is supplementary to angle 2, and that's because of a straight angle. This is a straight angle, 180 degrees, so they're supplementary. And that's a straight angle, so they're 180 supplementary. And now that means that angle 5 is equal to angle 6, and it's SAT, supplement angle theorem. Supplements of these angles are supplementary. These are supplementary. 1 is equal to 2, so 5 is equal to 6. And now we have a given. So because of this given, we have VK equals VT, and that's the definition of a segment bisector. Because HV bisects KT, it cuts KT into two equal pieces. And now we have these 5 is equal to 6, so now we have HK equals HT, and it's converse of ITT, which means these two angles are equal in this triangle HKT, so these two sides are equal. And now we have 5 equals 6, and we have KT, and we have KV, KH, so we have it all. So we have this side equals this side equals this, and these angles in between equal. So triangle HVK is congruent to triangle HVT. And the reason is side angle side. Congruency. And number 8, That means we have angle 3 equals angle 4. And that's congruent, parts of congruent triangles congruent. And number 9 is that HV bisects angle KHT, definition of an angle bisector. 3 is equal to 4, so that means that HV is bisecting the angle. And how did you make out? Hopefully great. And let's do number 2. Again, pause the video and work it out before I do. We have a triangle. It says that EH is an altitude, and an altitude leaves the vertex and goes perpendicular to the opposite side. And it also says that EH is a median. A median leaves the vertex and goes to the midpoint of the opposite side. So H is a midpoint. So because we have these two angles, because it's perpendicular, these two angles are going to be equal. So let's name them 1 and 2. Because we have a midpoint, that means that HC is going to equal HO. And we have HE is a common side. So these triangles are congruent. And we have to prove that, oh, I forgot to mention, we have to prove that ECO is isosceles. To get ECO as isosceles, we have to prove two sides equal. So we can prove that this side equals this side. I'll do it with an exclamation mark. Or you can do it with a question mark, whatever you want. So if I get these two sides equal, then I have an isosceles triangle. How do I get these two sides equal, EO, EC? By getting a pair of congruent triangles. Here we go. Number 1, EH, oops, that's good. Start off already. EH is an altitude of the triangle. Altitude of triangle ECO, and that's a given. Because it's an altitude, EH is perpendicular to CO. Make that an O now, don't be careless. And that's the definition of an altitude of a triangle. And as a result of being an altitude, angle 1 is going to equal angle 2 because perpendicular segments form congruent or equal adjacent angles. You could say equal or congruent here, so if you want to say equal, mark the 2 strokes. Forms congruent, forms equal adjacent angles. Number 4, and we have that EH is a median of triangle ECO, and that's a given. And as a result, that means that H is a midpoint of CO, and that's the definition of a median of a triangle. Make that a triangle. And that means, because that's a midpoint, that means HC is equal to HO. Definition of a midpoint. Midpoint forms 2 equal parts. And now we have EH equals EH. And that's a common side. EH is common to both triangles. So now we have triangle EHC congruent to triangle EHO. And that's side angle side. And as a result of that, we have EC equals EO. that's CPCTC. Congruent parts of congruent triangles are congruent, and because they're equal, that means the triangle ECO is isosceles. And definition of an isosceles triangle. To get an isosceles triangle, you need two sides equal. Okay, let's continue another proof. Now, let's see what we have here. We have given angle E is equal to angle F. And angle EHG, angle EHG is this one, is equal to FGH, which is this one. That's the big angle. I have it marked with double strokes. And it says prove that AH is equal to AG. So, let's try this first. Let's try these two triangles, E, H, and F, G intersecting at A. Can we get, if we can get these two triangles congruent, then AH is equal to AG by CPCTC. So the only angle we have is, this is so. We have angle E is equal to, oh, that's an F. Again, I gotta be careful. Sometimes I make errors, as I said I do. Gotta catch myself. So we have angle E equals angle F. We have two angles, but I need a side. But I don't have any sides. So I can't go this way. So that means I have to look at these triangles. So I have to look at E, H, G, and F, H, G. And what we have here is angle E is equal to angle F given. We have EHG, which is this one, equals to FGH, which is this one. And we have two sides equal, two angles equal, that's given. And we notice that HG equals GH, common side. So these triangles are congruent by AAS. And therefore, we have, now how do we get to these two sides? Well, what happens is that this angle right here at 1 is going to equal this angle at 2. So this angle right here is going to equal this one. And there they are right here. So that angle is, let's see, AH is right in that corner. So it's EG, so there's one right there. And there's two there. So EGH is the same as AGH is 1. And there's 2. FGH is right here. So we get these two angles equal, CBCDC. These angles are in this triangle AHG. Because these angles are equal, that means these sides are equal by converse of ITT. So here we go. Always a way to do proofs. You just got to be ready to think. So I'm going to put all these givens in number 1. And we have HG equals GH, common side. As a common side to these two triangles, EHG and FGH. And that means the triangle EHG is congruent to triangle FGH. by, again, what do we have? We have an angle, this angle with this angle, and this side is common. So we have an AAS congruency, and as a result, we have angle 1 equals angle 2, angle 1 equals angle 2, CPCTC, because they're in these two triangles, and as a result, we have AH equals AG converse of ITT. And again, you can see that they're overlapping triangles. You have to be careful. So that's why I drew this pair of triangles first to see if I can get AH equals AG. I couldn't. So I had to think about going after the overlapping triangles, the bigger triangles. And one more proof to do to end off the unit on congruent triangles. Very important to know how to prove triangles congruent because it's needed when you do the unit on proving quadrilaterals, parallelogram, rhombi, squares, etc., etc. And in this diagram, we're given that AB, which is this one, equals PC, which is this one. We're given that AP equals BCB, which is this one. And we're given that XE bisects AC. So XE bisects AC. So that means OA equals OC. And I need to prove that OX, which is this side, is equal to OE. So to get these two, let's see if we can draw that. So we have this situation. Oh, further down. So I'm checking. I need to get OX. I'm trying to get these two triangles, AXO and CEO. So AOXBC. So I have, because of the bisector, I have this OA equals OC. Because of the bisector, I also have this angle equals this one, but I don't have any. The only way I can prove this triangle congruent, I have to get these OX equals OC, so I can't use this right now. That would be an SAS. So I need another angle, but I can't get an angle. So that means I have to go after proving another triangle congruent. So I got to prove another pair of bigger triangles, or another pair of triangles, to either get this angle A equals angle C, or the angle at X here equals the angle E. So I will draw these two triangles. So A, P, C, and A, B, C. These big ones right here, and this one right here. Here they are down here. So AB is equal to CP. AP is equal to BC. And we have this common side. So these triangles are congruent by SSS. And because these triangles are congruent, then I can have this angle at A right here, this one, equals this one. So I can have these two angles equal. So we'll name this one 1 and 2. Because A, B, C is congruent to C, P, A, these two triangles, big triangles, are congruent here. So there's 1 and there's 2. These two angles are equal. And now I have this side equals this one because of the bisector. Then I have 3 is equal to 4 because of VOAT. Now I have this triangle XOA equals EOC by angle side angle, and that gives us OX equals OE. So that's the proof. But let's fill in the statements first. This is the statements column. This is the reasons column. And we'll put AP equals CP and AP equals CB. We'll put that all in one because we're going to use those in the large triangles. So AC is equal to CA. Common side. So that means the triangle ABC is congruent to the triangle CPA, and it's a SSS congruency. Here it is down right here. And as a result, we have the angle 1 equals angle 2. Angle 1 equals angle 2. The angle 1 is BAC. BAC is angle 1, and PCA is angle 2. And they're CPCTC in these two triangles. And now we have angle 3 is equal to angle 4. VOAT, vertically opposite angle theorem, or VAT. If two lines, two segments intersect, then the vertically opposite angles are equal. Now we have a bisector that we're going to use, XE bisects AC, that's a given. And as a result of that bisector, that it bisects, so OA equals OC. Definition of a, spell segment out this time, segment bisector, B-I-S-E, bisect. And as a result, because we have 1 equals 2, 3 equals 4, and OA equals OC, we have triangle AOX congruent to A goes with C, O goes with O, X goes with E, and that's an angle side angle congruency. And as a result of these two triangles congruent, OX equals OE. American number 9, CPCTC. So that brings us to the end of our proofs. Hopefully, if you went through all my videos on congruent triangle proofs, you have a better understanding. The thing is, a better understanding, filling in the reasons, and working out your proofs. And I thank you for viewing my video. And if you like my video, click on the like button, subscribe button, notification bell. Visit my website, www.mathsfullyexplained.com, to find more information about me, my videos, and the content on my YouTube channel called Math Fully Explained. Thank you very much. Bye-bye.